Myself, Dr. Somit De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities. So this is my lecture number 6 under module number 1. Topic is gamma function. Module name, module calculus integration. Paper name mathematics 1A, paper code BSM-101. This subject belongs to BTech first semester, stream computer science and information technology. In my last lecture, that is in lecture number 6, I had discussed improper integration, basics of compound integral. There are two types of improper integration you have. Type 1, where you can see upper and lower limit, that is your range of integrations is associated with the infinity. There are two types. There are two types of integration. For three possibility you have: lower limit as infinity, upper limit as infinity, upper limit, lower limit are also associated with the infinity. In second type, where your upper and lower limit are both are finite, but your function, that is integrand, is unbounded either at lower point, lower limit, or upper limit, or any point in between the range of integration. So I discuss. So this gamma function is also a special type of improper integral. So using this concept, you can solve lots of question right now, and you can in future also. So if any question improper integration, if any improper integration you have, if you can express this improper integral into this gamma form, then you can solve this particular problem very easily. Now try to understand how to what is gamma function and how to apply it. Try to understand. Very simple. Gamma function. So gamma is a special notation you have. Special notation. Basically, this one. Gamma n. Okay. So this is special notation you have. Now, gamma function is defined as follows: gamma n is equals to 0 to infinity e to the power minus x to the power n minus 1 dx, where n is positive. So this is the main condition. Correct? This is main condition. Your n should be positive. Now we can write gamma n is equal to 0 to 1 e to the power minus x to the power n plus 1 dx plus 1 to infinity e to the power minus x to the power n minus 1 dx. We know that if n is less than 1, then 0 is a point of infinity, infinite discontinuity, and hence 0 to 1 e to the power minus x to the power n is an improper integral having integrand unbounded at 0. Okay. Now there are some properties you have in gamma function. Gamma 1. So gamma n. So here n equals to 1 from the definition. So gamma 1 is equals to 0 to infinity. So what is the formula? What is your formula you have? Try to understand. Very simple. Gamma n is equals to 0 to infinity e to the power minus x to the power n minus 1 into dx. So here n is equals to how much? Here n is equals to 1. Correct? Here n equals to 1. So 0 to infinity to the power minus x to the power 1 minus 1 0 dx. So ultimately you have 0 to infinity to the power minus x dx. So that means limit. So your infinity is improper integration type. So you can write limit a tends to, you may write x also, no problem. Suppose I am taking here a, capital A tends to infinity 0 to a to the power minus x dx. Limit x tends to a, so integration of e to the power minus x is equals to minus e to the power minus x. 0 to a, upper limit, lower limit. So after substituting the upper limit, lower limit, what you have? Limit a tends to infinity, 1 minus e to the power minus a. When you consider a tends to infinity, that e to the power minus infinity goes to 0. Ultimately, you have 1. So from it is clear, if you have in anywhere, you can see gamma 1 is equals to 1, you can write. So this is also very important property. So sometime you can see the question, prove that gamma 1 is equals to 1. Basically what we are doing here, your n is equals to 1. Then you substitute the value n equals to 1 to the gamma function. Then simple integration is there. By using simple integration, you can prove that gamma 1 is equals to 1. Next. So this is also very important property. Gamma n plus 1 is equals to n gamma n. So by using this property, you can solve lots of question from gamma function. Let's see. So gamma n plus 1, what we are doing, ultimately your n replaced by n plus 1. Okay, so limit gamma n plus 1 is equals to 0 to infinity e to the power minus x, x to the power n plus 1 minus 1. So n plus 1 minus 1 cancel, that is you have e to the power minus x, x to the power n dx is equals to limit. Now you have upper limit is infinity, so you may write a tends to infinity 0 to a e to the power minus x, x to the power n dx. By using by parts you can solve it. So limit a tends to infinity minus e to the power minus x to the power a to a 0 to a plus n 0 to infinity 0 to a e to the power minus x, x to the power n minus 1 dx by integration of by parts technique. So when you substitute the value upper limit, lower limit, upper limit is minus e to the power minus a to the power n, and when you lower limit is 0, ultimately 0. So plus n, limit a tends to infinity 0 to a e to the power minus x, x to the power n minus 1, x to the n minus 1 dx. So ultimately when a tends to infinity, so this e to the power minus a goes to 0. Ultimately from here we are getting 0. So you have plus n 0 to infinity e to the power minus x, x to the power n minus 1 dx, so which is nothing but a gamma n. So ultimately you have n gamma n. So here we have proved that gamma n plus 1 is equals to n gamma n. So this type of proof you can see in your question paper also. Now this is the extension part, you can apply. So this is a direct proof. So another proof you can see, so gamma n plus 1, so from here it is clear. Try to understand another proof. This is also very important. Try to understand. So what you are getting from the last calculation, that gamma n plus 1 is equals to n gamma n. So formula declares that something plus 1 is equals to this n outside and this n inside. Okay, so we want to apply the same technique to establish another property. So gamma n, you may write gamma n minus 1 plus 1. Yes, you absolutely correct. So what is something that is n minus 1? So if we can using this property, that is n gamma n, similarly n minus 1 gamma n minus 1. Same way, this n minus 1 can be rewrite this gamma n minus 2 plus 1 is nothing but this. So similarly, you can write n minus 1, n minus 2, gamma n minus 2. Similarly, you can write this n minus 2 as a gamma n minus 3 plus 1. Something plus 1, so that means you can write gamma n minus 1, gamma n minus 2, n minus 1, n minus 2, n minus 3, gamma n minus s. Similarly, if we continue this process, so where we can see n minus 1, n minus 2, it should be 2. It should be 2. this typing mistake. It should be 2 and then and continue 3 to gamma 1. So gamma 1 is equals to 1 already you know. So from it is clear n minus 1, n minus 2, n minus 3 dot 3 to 1. So ultimately what is this? This is a factorial n minus 1. So gamma n plus 1. So from here it is clear that gamma n is equals to factorial minus 1. So we can rewrite this gamma n plus 1 is equals to factorial n. This is not correct expression. Basically what you have, this is also incorrect. Basically you have factorial n plus 1 minus 1, that is factorial n. Okay. This also, suppose you have a question in your mind. So this result is coming from previous from here. Then which one should I apply? So ultimately you have, what you have, gamma n plus 1 is equals to n gamma n and factorial n. So factorial n if n positive integer. If your n is a positive integer, then only you can use factorial n, otherwise you can apply the general form. Okay, this is very, very important property for you. Now, so another property, number 3, for a tends to 0, a positive, a to infinity, e to the power minus x, x to the power n minus 1, dx is equals to gamma n by a to the power n. Let y is equals to x, then dy is equals to a dx. So when x tends to 0 and infinity, so y tends to 0 and infinity. When x, then y tends to 0. When x tends to infinity, y tends to infinity. So 0 to infinity, e to the power minus ax, x to the power n minus 1 dx is equals to 0 to infinity, e to the power minus y, y to the power n minus 1, a to the power n minus 1 dy by a. So after simplification, what we have, 1 by a to the power n 0 to infinity to the power minus y, y to the power n minus 1 dy. So this is nothing but a gamma function. So you may write gamma n by a to the power n. So from here it is clear that third property you have from gamma function, 0 to infinity e to the power minus ax, x to the power n minus 1 dx is equals to gamma n by a to the power n. So this is also very, very important property that you have. Number 1. Number 4. This also, so here in gamma there are only four property you have. Okay. 0 less than m less than 1, gamma m, gamma 1 minus m is equals to pi cosec m pi. So I will give you some example for your better understanding, especially application of this property. So number 1 is gamma 1 is equals to 1, gamma n plus 1 is equals to n gamma n or factorial n. Number 3, 0 to infinity e to the power minus x, x to the power n minus 1 is equals to gamma n by a to the power n. And fourth number, gamma m into gamma 1 minus m is equals to pi cosec m pi, where m value lies between 0 and 1. Okay, so this type of question you can see in your question paper. Prove that 0 to infinity e to the power minus 9x, x to the power 3 by 2 dx is equals to 9 by 4 root pi. So now 0 to infinity gamma function type, e to the power x is your requirement, but you have e to the power minus 9x. So that means this 9x creates a problem. So that's why you should consider the 9x is equals to z. So dx is equals to dz by 9. Now you replace 0 to infinity e to the power minus 9x, x to the power 3 by 2, dx is equals to 0 to infinity to the power minus z. Sorry. What is x? X is equals to z by 9. So that's why I'm writing z by 9 whole to the power 3 by 2. What is dx? Dx is equal to dz by 9. So ultimately, after simplification, what you have? 27 by 9 after simplification you have this 0 to infinity to the power minus z, z to the power 3 by 2 dz. So 0 to infinity to the power minus z, z to the power minus 5 by 2 minus 1. I think you have a question in your mind, from where you have this. Very simple, try to understand, very simple logic. What you have? 0 to infinity e to the power minus z, z to the power 3 by 2 into dz. What is your requirement? Your requirement, this portion should be something minus 1, that is n minus 1. So that's why you should write n minus 1 is equals to 3 by 2. So from here you may write n is equals to 3 by 2 plus 1 is equals to 5 by 2. So that's why I am writing this. Now you know n, so that is 5 by 2 minus 1. So this is the logic. Your n is equals to 5 by 2. Very simple. Just to check whatever the power you have, you should consider n minus 1 is equals to that expression. So you have to find from this relation, you have to find the value of n. Now substitute here. Now from here it is clear 3. So n equals to 5 by 2. So gamma 5 by 2. So here it is clear that 5 by 2 is above 1. So that's why this 5 by 2 can be expressed 3 by 2 plus 1 formula wise. What is your formula? Your formula is gamma n plus 1 is equals to n gamma n. So that means if you can express something something plus 1, then only you can apply this. It means your result should be above 1. So from here it is clear that is 5 by 2 is above 1. So you may write 3 by 2 plus 1. So using this property, you may write 3 by 2 outside and 3 by 2 inside. Again 3 by 2, again 3 by 2 is more than 1. So you can write gamma half plus 1. Same way, this half should be inside, half should be outside as well as inside. So 9 by 4, so gamma half is equal to root pi. Please memorize one important value, that is one important value from gamma function, that is gamma half is equals to root pi. This is also most important value. Okay. So that is after simplification what we have, that is 9 by 4 root pi. So this calculation will continue until and unless your n value is less than 1. Okay. And this gamma n should not be negative. So you know from the definition of gamma function. Okay. So this calculation is clear. I repeat once again. So this is the process by which you can extract n. Then you can write 5 by 2 minus n dz. That is this is a gamma 5 by 2. Just to check whatever you have. That is always you check above 1 or not. If less than 1, so you can stop the calculation. If above 1, then try to express something plus 1. That is 3 by 2 plus 1. You can get, if you simplify, then you have a 5 by 2, that is 3 by 2 outside, 3 by 2 inside. Again 3 by 2 above 1. So that's why half plus 1, that is half outside, half inside. Ultimate you have after simplification 9 by 4 root 4. So this is very, very important question for you. Next, this is very, very important question. Prove that This is a university question, similar type question you can expect. Prove that minus infinity to the power minus x squared dx is equals to root pi. Since e to the power minus x square is an even function. Why? So already you know from the definition of even function that if I can consider fx is equals to the power minus x square. So f of minus x is equals to e to the power minus of minus x whole square is equals to the power minus x square is equals to f of x. So that means your function is an even function. Okay. So from the concept of definite integral, so even function 0 to infinity to the power minus x square dx is equals to, you may write 0 to 2 into 0 to infinity to the power minus x square dx. This is also a very important property from definite integrals. Okay. Now, so 0 to infinity you have is a gamma function. So what is the problem? E to the power your requirement is minus x, but here you have x square. So you should consider x square as a z. So then 2x dx is equals to dz. So 2 e to the power 0 to infinity to the power minus x square dx is equals to 2 0 to infinity to the power minus z, z to the power minus half dz by 2. Now, from where you have this? What is z? What is x? Because dx, again I should write. Please check carefully. Ultimately, what you have, that is 2x, that is 2x dx is equals to dz. That is dx is equals to dz by 2x. What is this? dz by 2 root under z. Clear or not? Because x is equals to x square equals to z, that is x equals to root z. So you may write, so when you substitute dx equals to dz by 2 root z, you have this. Now same way, so minus half you have, same. What is our target? Target to express n minus 1. So you may write n minus 1 is equals to minus half, that is this one. Okay, so what we are getting, n is equals to 1 minus half is equals to half, n is equals to half. So that's why I'm writing half minus 1. Clear? So these two cancel, these two cancel. What you have? 0 to infinity e to the power minus z, z to the power minus half plus 1 minus half, half minus 1 dz, that is gamma half. What is your gamma half? Gamma half is equals to root pi. Therefore, minus infinity e to the power minus x square dx is equals to root pi. This is very, very important question for you. Thank you. So this is all about gamma function and related question. Try to solve similar type of question from gamma function.